Today we'll solve systems of linear equations with three variables using an augmented matrix. We have our three equations, so let's put it in a matrix. So we have 1, -1, 1, and 2. So those are your coefficients that you can see here, and this is your answer. And here you see 2, 1, 3, 10, 3, -1, -1, 1. We have our first equation here, second here, third here. We have variable x here, y here, z here, and the answers here, and we only put the coefficients. Row 1 is going to be our pivot row, and then we want to have zeros here and here. So we start by multiplying row 1 by 2 and subtract it with row 2. And we will also multiply row 1 by 3 and subtract it with row 3. So like that, we will have zeros here and 0 here. And pivot row will not change, so this is going to be the same. And then since we have zeros here, these are the operations we are going to perform, like that. So 2 times row 1 is going to be 2 minus 2, that's 0. So -1 times 2 minus 1, that gives us -3. Then 2 times 1 minus the 3, that's -1. Then 2 times the 2 minus the 10 is going to give us -6. Then for row 3, we have 3 times 1 minus 3, that's 0. 3 times -1 minus -1, that is -2. 3 times 1 minus -1, that is 4. 3 times 2 minus 1, that is 5. Then we will take the second row as our pivot, and we want to have 1 here. So row 2 divided by -3. Like that, we have 1 here. Then this gives us 1/3, and here it's 2. We didn't do anything to the other rows, so just copy. Then we want to have zeros here, so we will perform these operations, row 1 plus row 2, and 2 times row 2 plus row 3. Our pivot row won't change, so it's just the same. And here, 1 plus the 0, so that's just 1, -1 plus the 1, that's 0, 1 plus 1/3, that is 4/3, 2 plus 2, that is 4. 2 times the 0 plus the 0, that is just 0. 2 times 1 minus 2, that is 0. 2 times 1/3 plus the 4, that is 14/3. 2 times the 2 plus the 5, that is 9. Then our pivot row will be row 3, and we want to have 1 here. So for that, we will take row 3 and divide it by 14/3, which will make it like this. We didn't do anything to the other rows, so just copy. Then we want to have zeros here, so we will do row 1 minus the 4/3 of row 3, and row 2 minus the 1/3 of row 3. Pivot row doesn't change. Then this one is 1 minus the 4/3 of 0, which is just 1. Then 0, 0, 10 over 7. Then 0, 1, 0, 19 over 14. Now, if we interpret this result, this is x, this is y, and z. So x is equal to 10 over 7, y is equal to 19 over 14, z is equal to 27 over 14. This is a case of unique solution. We have 1 in diagonal and zeros everywhere.